Okay, today we're going to be talking about piecewise functions, and a piecewise function is whenever you have one function that has a different function rule for different parts of the domain. Now, domain is going to be all the values that x can take on to make the statement true. So what this means is I'm going to evaluate negative 2x plus 4 for only when the values for x are greater than or equal to 4. Example of that would be 5, 6, 10, 15, 132. Okay? However, I'm going to use 6x plus 1 for all the values that are below 4, such as 3, 2, negative 15, negative 22. Those are examples. So the very first thing that you want to do is you want to take the number that they have that they've given you. They've given me a 2. And it says that they want me to evaluate the f function at the value 2. So you have to figure out, where does 2 fall? Does 2 fall in this domain region where it's greater than or equal to 4? Or does 2 fall below 4? So you need to compare and contrast the values 2 and 4. 2 is less than 4, so since 2 is less than 4, that means I'm going to be utilizing the 6x plus 1 part of the piecewise function. So I'm simply going to plug in 2 for x, and I'm going to calculate, and that's going to give me a 13. Now, when you plug in, you're plugging in for x, and you're going to chug out a y. So this gives me the ordered pair 2, 13. And you could physically graph that on your graphing calculator or on your graph paper. So again, I give you the ordered pair. This time, I give you 6. Where does 6 fall? Is 6 going to be what compared to 4? 6 is greater than 4. So since 6 is greater than 4, I'm going to use the top part of this function, which is negative 2x plus 4. Every place I see an x, I'm going to plug in the value 6. So that's negative 2 times 6 plus 4. Negative 12 plus 4 is going to give us a negative 8. So now I have the ordered pair 6, negative 8. Okay? Next part is now I'm giving you the value 4. So what is 4 compared to 4? It is equal to it. So which of these domain regions allows me to be the value 4? The top one says greater than or equal to. The bottom one says strictly less than. So that means I'm going to be utilizing the top part of the function, which is negative 2x plus 4. And every place you see an x, you are going to plug in the value 4. Negative 2 times 4 plus 4. So that's going to give me negative 8 plus 4, which is going to be negative 4. So that gives me the ordered pair 4, negative 4. Okay, let's go ahead and do this again. I'm going to give you a different piecewise function this time. This piecewise function says that I'm going to use x squared plus x minus 2 for whenever the values are greater than 0. This bottom one of 2x minus 10 is going to be used for 0 and below. So we're going to go ahead and we're going to compare negative 4. Where does negative 4 compare to 0? Well, negative 4 is less than it, so therefore I'm going to be utilizing the 2x minus 10. So I'm going to simply plug in a negative 4. So that's negative 8 minus 10, which is negative 18. So I have the ordered pair negative 4, negative 18. Okay, moving right along. The next one is 0. I'm going to compare 0 to 0. 0 is equal to 0. So which of these domains allows me to be 0? The answer to that is going to be 2x minus 10, which is the bottom one. Okay? So I'm going to plug in a 0 there, and that's going to give me 2 times 0 minus 10, which is just negative 10. So now I'm going to have the ordered pair 0, negative 10. And my last one is going to be 3. What is 3 compared to 0? It is greater than it. So I'm going to be utilizing the top part of the function this time. And I'm going to go ahead and I'm going to put a 3 in parentheses. So that's 9 plus 3 minus 2. So that's 12 minus 2, which is going to be 10. So give me the ordered pair 3, 10. Okay? Now, notice I put these in parentheses here. And the reason why I did this is because if it would be a negative number, you would have to square that negative along with the number. So oftentimes that's where a lot of people make mistakes. So if you put parentheses there every time you are plugging in a number, it makes sure that you are squaring the negative if you have a negative number. Okay? Last example I'm going to give you in this part. This time I give you 3 parts of a piecewise function. So I'm going to use x plus 8 only between -5 and -3. So if it's below -5, I can't do the function because there's not a number below -5 I can plug in for. So if, again, I can only use x plus 8 between -5 and -3. If it is a number below -5, such as -6 or -10, I'm not able to utilize that value. Okay, the second part is 3, and I'm going to utilize that between -3, and it can be -3, to +1, but it cannot be 1. And then 3x minus 6 between 1 and 3. So with that being said, we have to do a little bit of comparing. So my comparing is, where does -3 fall? Does -3 fall here, here, or here? It is not in this one, and it's in both of these, but this one right here says it's strictly not equal to, so it can't be this one. So that means I'm utilizing this value right here. So I'm going to use the function 3, but I can't plug anything into it because there's no letter. So what this means is I just simply have the ordered pair -3, +3. There's no variable to plug in, but that doesn't mean that I still am not utilizing that function. Okay? Next, -6. So now I'm going to do this all over again over here. Okay? And I'm going to have -6 at each one of these. Does -6 fall here? Nope. Does -6 fall here? Nope. Does -6 fall here? Nope. So what does that mean? Can I evaluate this function at -6? Does it fit into any of the domain categories? The answer to that is no, it does not. So therefore, this is not possible. Or no solution. Okay? So let's go ahead and do this again. For my next value, which is going to be 2, where does 2 fit? Is 2 between -5 and -3? No, it is not. Is 2 between -3 and +1? No, it is not. Is 2 between 1 and 3? Yes, it is. So I'm going to be utilizing 3x minus 6, and I'm simply going to plug in an x, so that's 3 times 2 minus 6, so that's 6 minus 6, which is 0, to give me the ordered pair 2, 0. And that is how you are going to do tonight's homework. Now, there's one other topic on there that we need to talk about, and this is how you graph. How do I physically graph a piecewise function? So, I have 3 graphs that I have to graph. I have to graph y is equal to x plus 1, y is equal to 3, and y is equal to 3x minus 2. Those are the 3 lines I have to graph, and I'm going to put them all together. And I'm going to cut them off at the values that it tells me that I have to use it for. So I'm going to graph x plus 1. That means I have a y-intercept of 0, 1, and a slope of 1. So I start at 0, 1. I rise up 1 to the right 1. Okay? So here's my line. This is my line. I'm only going to utilize this line between -5 and -3. Do we see that? So I'm simply just going to shrink this line down. I'm going to shrink this line down. Okay? And I'm going to only use it need a couple more points there so that I can see it a little bit easier. Okay, so I'm going to shrink this down, and that's what I'm going to use it from. And I'm simply just going to erase all of those ordered pairs and my lines. So that's what I'm using that from. Now, I need to have a solid dot here, but an open dot right there, because it cannot be that value. Then I'm going to graph this one right here, which is going to be x is equal to 3. Well, x equals 3 is the solid line all the way across here. Okay? But I'm only going to use that between -3 and +1. And my line does not want to shorten for me. I'm going to use my mouse. It'll probably be a little bit easier. Okay. I'm actually just going to delete that one and see if I can get it a little bit better. I'm just going to draw it from -3 to +1. So there's my line. And again, I'm going to have a closed dot here. I'm going to have a closed dot here, but I'm going to have an open dot here. Okay? And then 3x minus 2. I'm going to start out my y-intercept, which is going to be 0, -2, and then I have a slope of 3/1. So 0, -2 is right here, and I'm going to go up 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. Now, I'm only going to use that between 1 and 3, so I'm going to connect these dots between 1 and 3. And actually, I'm going to stop right there because that's my 1, and I'm going to erase this. And that's going to between, it can equal 1, so I have a closed dot there, and it can equal 3, so I'm going to have a closed dot there. And that's how you graph it. I am really not worried about this one as much as the rest of the problems, but I do want you to try it, okay? Tonight's homework is going to be 2-4 concept byte, and I will go over and start your homework for you.